Hello, mechanics and materials students. In this very brief lecture, I'm going to describe to you a shorthand way of describing vectors and tensors, especially those types that we'll be using to describe stress and strain in mechanics of materials, and this is known as indicial or subscript notation. Chances are you've already seen this in some of your mathematics or physics classes, but this is a quick review just to get you ready to go for mechanics of materials. So this is known as a rigorous, it's a mathematical method of associating variables. And again, it is very good for matrix-based solutions. So in it, basically we have two types of subscripts. And to start with, the whole idea of indicial notation is you will have a variable or an expression, which is a main note. In this case, you can see down here we have A and B, and then you'll have a subscript, which is effectively a counter. And each counter will represent a different iteration of that variable with a change in some known other variable. Like subscript 1, 2, 3 could represent, usually in our case, 3 orthogonal directions. So x, y, z is 1, 2, 3 in most cases. So we can have a free subscript and that's something that's not repeated within any term, which is any product. Generally, sometimes a sum or a dummy subscript that is repeated, and those are treated a little bit differently in complex expressions, and those will be things that I point out as I go through derivations of expressions that get summarized as indicial expressions as we go through future lectures. But just to give you a look ahead, if we have a single subscript, we can describe a vector. So if I had a sub x, a sub y, a sub z to represent, say, the three components of a force or a moment vector, I could just simply write ai. The same things with a matrix. I could write bij. This time I put the hats over them as if they were unit vectors. These actually, it would be more accurate to just simply write them as without the hats. This is just these aren't unit vectors, they're just simple i's and j's. So I will index 1, 2, 3 for every one of j. J indexes to 2, I goes through 1 through 3, and this effectively forms a matrix. So I being denoting the row and j denoting the column position. So this is what's known in our mechanics of materials is known as a tensor. So stresses and strains will have tensors to denote basically the direction something's pointing or operating and the orientation of the face of a material volume element that it's operating on. So we can use indicial notation to basically summarize the x, y, z or faces and orientations of just about anything that we create a complex expression for. So you'll see them again. We can apply them indexing different ways. We don't necessarily have to index 1, 2, 3 for every variable. Just to give an idea, we could write PNMQN, and then if for whatever reason M was only valid for 2 states, we could basically write an expression for this written out in a summation form as summing over n 1 through 3 using both values for m. So this would give us basically a 2-component vertical vector, a vertical matrix. That this is a vector with 2 components, the first one being this summation, and in this case m1 is the first position in the vector, and then the n equals 1 through 3 is what is being indexed in the summation expression. This is just one example of ways to use an indexed indicial note there n, and then use m, and then use n for the summation. There's obviously we could have flipped it, and if we had summed on M, we would have gotten only a 2-component sum, but we would have had a 3-component vertical vector. So that's a whirlwind quick intro to indicial notation, just so that when you see it in upcoming derivations and summaries of expressions, it won't look too strange. But also for those of you who are going to go further in this field, that type of notation will represent the basis of a lot of numerical methods. So as you start to write computer programs to run through loops to create some of these stress-strain tensors in matrix form in a computer program, you'll be taking advantage of these types of indicial notations for loop counters as you go through calculations to create stress and strain tensors. So that is it for this quick intro. So look forward to seeing some shortcut expressions in indicial notation in upcoming derivations of stress-strain relationships.